In the last section, we started extracting some logic from our main.dart file over to this new custom app widget that we have started working on. We got through comment number 1 up here, and we're now going to continue with the second step, which is the second comment right here. So in the second step, we need to create a class that is going to extend the base stateless widget class. To do so, we're going to first just write out the code for this, and then we'll talk about what it's doing. So the code that we need right here is class app extends stateless widget. Okay, you might see a little red squiggly under app that says missing concrete implementation. You can completely ignore that error message for right now. We're going to fix that up in just a moment. What's more important is what's going on with the syntax right here, and even more importantly, what a stateless widget is. So first off, the syntax. This defines a new class called app that's going to take all the functionality inside of the base class of stateless widget and add some additional methods and instance variables on top. This right here is classic object-oriented programming. So we're taking a base class and extending it with some additional functionality. We would now refer to our class app as a subclass of stateless widget. Okay, so the idea of extending a class, again, classic object-oriented programming, not the worst thing in the world. What is a little bit more confusing is exactly what a stateless widget is. So let's take a look at a diagram that's going to clarify that. Okay. So in the last couple of sections, I've been using the term widget over and over and over. A widget in Flutter is not only a concept of something that controls some element that gets displayed on the screen of our mobile device, but it's also a class. So in Flutter, there is a class called widget, and it contains a bunch of functions and different instance variables that assist it in showing some content on the screen of our device. From this widget class, there are two subclasses. One is called stateless widget, and the other one is called stateful. There's one difference between these two classes, and it solely comes down to whether or not the widget that we're trying to create is going to maintain its own state or its own data. So if we are creating a custom widget where we expect our widget to never have to essentially maintain its own source of data, we will create a stateless widget. If we expect to have to create a custom widget that's going to eventually have to control its own source of data or go fetch its own data or somehow generate and maintain its own state, we will instead create a stateful widget. Now, if these terms of maintain data and state don't make any sense to you, that's totally fine. Let me try putting this a different way. If you are trying to create a widget, as we are right here, and you expect this thing to eventually have to maintain its own local instance variable that has to change over time, let's say we're making some counting application, and for that we would want to make some counter variable that starts off at 0, and then we would maybe want to increment this counter over time. If you expect to have to write code like this right here, then you do not want a stateless widget. We only use a stateless widget when we do not expect to have to add in an instance variable that's going to change. In our case, our app widget for right now does really not appear to have any data tied to it that's going to change over time. Now, once we add in this idea of fetching images and whatnot, maybe that's going to change, but for right now, just for what we have at this point in time, it has no data tied to it that's going to change. And that's why I chose to use a stateless widget right here, rather than a stateful widget. Okay, so that's step number 2. Now let's again take a quick break. We're going to come back to the next section, and we're going to start working on this build method thing right here. So quick break, and I'll see you in just a minute. In the last section, we accomplished step number 2 of creating our own custom widget. We're now going to move on to step number 3, which says that we have to define a build method inside of our class. And that build method has to return the widgets that our custom widget is going to show on the screen. I'm going to first get started by moving this comment into the class body itself, because the comment itself is saying we have to add a method to the class we just created. So then inside the class, I'm going to add a method called build, like so. The build function right here is always going to return something called a widget type. So I'm going to annotate the return type as being widget, like so. you'll notice that we have a red squiggly right here. If you read the text, it says invalid override, and then it gives you a little bit of information. Now, what this error is complaining about right now is that we have defined a build method on our widget that currently takes no arguments and returns a widget. But if we are going to extend the stateless widget right here, then you and I are required to define a build method that returns a widget, but also accepts a value type of build context. So in other words, that error message is saying, okay, you know what? You defined a build method. That's great. I'm happy you did that. You're trying to return a widget. That's good. I'm happy with that. But you know what? Your build method, it has to return, or excuse me, accept an argument of something called a build context. So it wants us to receive that argument like so. So we refer to this single argument to this build function as context. We're not going to use context just yet. Okay, so we're going to hold off on a definition of what this context thing is. So for just right now, all we need to understand is that if we're going to define this build method, we have to accept an argument called context, and we'll come back to this later on and talk about why we are receiving this thing. It's going to end up being very important and very relevant to some of the later applications we work on, but for right now, we don't need to worry about context. So now inside this build method, we're going to return all the widgets that our custom widget is going to show when it appears on the screen. And so for this step, we get to do something really easy. We're going to go back over to our main function right here. We're going to select all of these different widgets that we had put together. So everything from material app down here to the bottom. I'm going to cut all that out. I'm going to go back over to my build function right here, and I'm going to return and then paste all the stuff that we just copied. I'll then save the file, and all the formatting kicks in automatically. Okay, so now we just defined our build method. Now anytime we try to show our custom app widget on the screen, Flutter is going to automatically call this build method right here. It's going to take all the different widgets that we return, and it's going to try to show all those widgets directly on the screen for us. All right, and that's pretty much it. That's our three-step process. So at the top, we did our import. We created our class that extended a base class of stateless widget. Then inside of our class app, we defined our build method that returned all the widgets that our app widget is going to show on the screen. So let's pause right here. When we come back to the next section, we're going to fix up our main.dart file and make sure that we import in that new app widget we just created, and make sure that we try to show an instance of that app widget with our run app function. So quick break, and we'll take care of that in the next section. In the last section, we finished up our custom widget of app. We're going to come back to this file in just a little bit and do a better review of exactly what we accomplished in here, complete with a couple diagrams to give you a better idea of exactly what's going on here. But for right now, I just want to get our application working. I'm now going to flip back over to my main.dart file. So inside of this file, we want to import that new app widget that we just created, and then pass that app widget off to the run app function, which you'll recall takes a widget and shows it on the screen of our mobile device. So in order to get access to that custom app widget we just created, we have to add an import statement to the main.dart file. We've already spoken about import statements when we are importing files from an outside package. But this time around, we are importing a file that is defined inside of our own local project. To do so, we're going to write out a slightly different import statement than the one we did before. Let's first start off by taking a look at a quick diagram to give you a better idea of how we're going to write this import. Okay, so this right here is the complete story around imports. This covers the three different types of import statements that we're going to write inside of our Flutter applications. It covers the case in which we are importing code from the Dart standard library, in which we are importing a file in our lib directory to another file inside of our lib directory, so essentially importing a file that you and I wrote ourselves, and then importing something into our lib directory from a package that has been installed into our project. So let's first start with the one down here, because this is the one that we just took care of. So again, if we want to import something into our lib folder or into a file in our lib folder from anything outside that lib folder. So an example of this would be some outside package. Then we would write import the word package, a colon, the package name, a slash, and then the name of the file that we want from that package. So again, this is the one that we've already done. Now let's go up to the very top because this is another very easy import statement. If we want to import anything from the Dart standard library, then we just write out import the word Dart, a colon, and then the name of the module from the Dart standard library that we want to import into our current file. We're going to have to write one of these import statements very shortly, so we'll come back to these in just a moment. So what we're going to do right now falls into this second case. We are trying to import something from our lib directory, or in other words, a file in our lib directory that you and I wrote, into another file inside our lib directory that you and I wrote. To do so, all we write out is the word import, the path to that file, like the relative path to that file, and then the name of the file that we are importing. And so both these import statements right here are examples of how we would import a sibling file. Now that starts to get a little bit complicated, so let's just flip back over to our code editor and I'll show you how we do this import statement for our particular case right now. Okay, so back over here, we are in a file inside of our lib directory, the main.dart file, and we want to import another file inside of our lib directory. Yes, it's nested inside of src, but ultimately the file is inside the lib directory. So we're going to write out import, then the path or the relative path to the file that we're trying to import. So I want to look into the src directory and find the app.dart file, like so. And that's it. So we're inside the main.dart directory. We're going to go into src and find the app.dart file. Okay, so that's pretty much it. That's the second case right here. And we're going to see an example of this first case up here in just a moment. So we'll come back to this diagram at that point. All right, so now back over here. The last thing we have to do, now that we are importing our custom app widget, we're going to make sure that our run app function right here attempts to show an instance of our app widget. So I'm going to remove this var app because we don't really need to define our app ahead of time. And then into run app, I will pass app with a set of parentheses like so. So again, this takes our app class, creates a new instance out of it, and then we pass that instance off to run app. All right, so let's save this file. I'll go back over to my terminal. I'm going to do a full reload with Shift-R, and then I'm just going to expect to see the exact same content appear on the screen. At this point, there should be no changes, except for the fact I think my button should probably go back to a plus down here because we just reverted that back to the icon add. And there we go. So there's my add icon and my app just successfully restarted. So this looks pretty good. We have now created our own custom widget defined inside of a separate file. We then imported it back to the main.dart file and successfully showed it on the screen. So the steps we just went through was just a little confusing. So let's take a quick pause. We're going to come back to the next section and we're just going to look at a diagram or two that's going to model out the current state of our application. So I'll see you in just a second. In the last section, we finished up a refactor that moved a bunch of logic from our main function inside of the main.dart file into a new custom widget that we defined inside of our app.dart file. Inside of the app.dart file, we created a new custom widget by defining a new class that extended the base class of stateless widget. We made this a stateless widget because we did not expect it to have to maintain any of its own data that would change over time. That might change at some point, and it might change very shortly, but at least for right now, it was a good place to get started. Anytime that we define a custom widget, we must define a method on that custom widget called build. The build method has three requirements. First off, it must be called build. That's obvious enough. Secondly, it must return a widget. Third, it must accept a single argument that we refer to as context. And you'll sometimes hear this referred to as the build context because that's technically the type of the value that gets passed in. We will eventually come back and talk a lot more about what this context thing is, but for right now, we're just going to gloss over it a little bit. So then inside of our build method, we assembled a new material app widget that had all of its own custom widgets nested inside of it. We then returned the entire thing. Then back over inside of our main.dart file, we imported the custom app widget that we just created. We then created a new instance of that widget and passed the instance off to the run app function. Then presumably behind the scenes, run app took that instance of our app widget and I assume at some point in time probably called this build method right here. It got back all these definitions of what our app is supposed to look like and then rendered all those widgets onto the screen of our mobile device. So that's a review of where we're at right now. Now before we move on, there's one last little concept I want to reveal here. Okay, so this is what we refer to as our widget tree, and it's a very handy way of visualizing all the different widgets that are being displayed inside of our application. So at this point, everything inside of our application is being rendered ultimately by the app widget that we just put together. The app widget is returning from its build method the material app widget. So as a direct child to the app, we have our material app. Then as a direct child to the material app, we have the scaffold that we put together. Then the scaffold itself shows two widgets, the floating action button and the app bar. And each of those are showing its own respective widgets of icon and text. So again, this is a handy way to picture our widgets as they are built inside of our application. And we're going to eventually create a couple of different diagrams like this to better understand the flow of data inside of our application when we start introducing state or data that changes over time inside of our app as well. Okay, so that's a good review. Let's take a quick pause right here. We're going to come back to the next section and we're going to start working on the next piece of functionality inside of our app. We've now got an app bar at the top of our screen. We've got our floating button down at the bottom right, and I think we're making a little bit of progress. As a quick reminder, the overall goal of our application is to make sure that every time a user presses the button right here, we show one additional image on the screen. So if the user presses the button 10 times, I want to show 10 images. Now, as we try to build out this application, if we just beeline trying to get those images on the screen, we're going to have to write out a lot of confusing code very quickly. So I want to take a little bit more incremental approach. So to get a little bit more incremental approach in building this application, we're going to set ourselves a little bit easier, more immediate goal. I want to add in a little piece of text on our screen for right now. So I want to add like a piece of text right there. By default, I want it to say 0 images. And then every time a user clicks on the button right here, I want to increment this text to stay like 1 images, 2, 3, 4, 5, and so on. So rather than showing an actual image, we're just going to have a little bit of text that increments every time the user presses that button. I know that sounds like it might be a little bit boring, but in reality, this little piece of text right here is very similar to what we're actually trying to do. Remember, every time we press the button, I want to show an additional image. So having a little counter is actually not that far off from what we're trying to accomplish. Okay, so let's talk about how we're going to achieve this, because it's actually going to be a little bit more complicated than you might think. So I want to first give you a quick reminder on some of the differences between stateless widgets and stateful widgets. Now we looked at this diagram previously, but I changed the text at the bottom just a little bit. Right now, our app widget is a stateless widget. That means that it has no instance variables that are going to change over time. And that's absolutely true of our app widget as it stands right now. But if we go back to our mockup right over here, clearly as we're pressing on that button, we're going to need to have some counter variable that's going to change over time. And I think that it's probably going to make sense to tie that counter variable to our app widget. So because we want to have a piece of information tied to a widget that's going to change over time, and we want those changes to be reflected on the screen of our device, we're going to have to refactor our app widget into a stateful widget instead. So this entire process that we're about to embark upon is going to be refactoring our stateless widget to be a stateful widget instead. Now, you might be thinking, okay, Stephen, whatever, that sounds good. let's go back over to our app component, app widget right here, and we'll just change stateless widget right here to stateful. Well, unfortunately, no, that doesn't quite work out. So this right here, not quite how we do that refactor. It's a much more involved process that's going to involve a couple of different steps. So I want to first tell you about exactly what we're going to do. Then we're going to do it, and we'll talk about what we did. So we're going to really cover this from all angles. All right, so here's the plan. In this section and the next one, we're going to first get started by doing a refactor of that app widget into a stateful widget. Right after that, we're going to have a quick discussion on a weird bit of syntax that we're going to see while we are doing that refactor. And then immediately after that, we'll talk about why these stateful widgets are so much more complicated to write than stateless ones. All right, that's the plan for the next couple of sections. So let's get started right now with that refactor. All right, so here's the guide. Here's what we need to do. So a couple different steps in here. We're going to first get started by breaking our widget, the app widget that we already put together, that class, into two separate classes. We're going to refer to one as the widget itself, and then the second class that we're going to add in, we're going to refer to as the widget's state. The widget state right here is going to be a class that contains the data that we want to wrap up inside of our widget. So in our case, it's probably going to be like an integer of some sort that counts the number of times that a user has pressed that button. So we'll start with this step right here first, and then we'll move on to the next one in just a moment. So I'm going to flip back over to my code editor. Here's my app.dart file with my app widget. I'm going to first get started by creating a second class inside of here, right above the existing one. I'm going to call this class app, and it's going to extend stateful widget. I'll then find the existing app widget we had put together, and I'm going to change the name of this one from simply app to app state, like so. And then I'm going to change extend stateless widget right here to something else, and this is where that weird bit of syntax that I just mentioned is going to come into play. So we're going to write out state. I'm going to put a less than sign, greater than sign, and then in between those, I'll write out app, like so. Okay, so that's step one of our refactor. Now, like I just said in that diagram 2 seconds ago, this is that weird bit of syntax right here. We're going to have an entire lecture to talk about what exactly is going on right here. So we will cover this in just a little bit, but for right now, we'll just leave it as is. All right, so at this point, we have now covered our step one right here of our multi-step process of refactoring a stateless widget into a stateful widget. So let's take a quick pause right now. We'll come back to the next section, and we'll move on to step two. In the last section, we started the refactoring process to turn our stateless app widget into a stateful widget instead. As a quick reminder, we're going through this entire process right now because our app widget is going to have a counter variable associated with it. That counter variable is going to change over time, and anytime it changes, we want to update the representation of that widget on the screen of our device. So because we have data that's going to change over time, and updating that data should be reflected on the screen of our device, we have to use a stateful widget. And we just accomplished step number one of that refactor. We're now going to move on to step number two, where we're going to add a createState method to the widget class. Whenever we call createState, it's going to return an instance of the widgetState class. So here's the widget class. This is the widgetState class. On the widget class, I'm going to add a method called createState. And from this thing, anytime someone calls this, I will return an instance of our widget state, or we are referring to it as the app state class. All right, so that's it for step number two. Now, again, I know these steps are pretty confusing and they probably seem a little bit arbitrary. Once we get through all these steps, we will have a discussion on why we have to do all these crazy things in here. Let's just keep going for right now and get our code on the screen. So the next thing we have to do is add a build method to the widget state class. So this is the widget state class right here. And as you can see, we already have our build method on here. Our build method is returning all the widgets that our widget is going to show on the screen. So no work required for step number three right here. I just included it on this list to be complete. On to step number four. So now we're going to add some instance variables to the widget state class. and these instance variables are going to represent the data that we're going to have that's going to change over time. So on my widget state class right here, I'm going to add on an instance variable that I'll call counter. I'll make it an integer, and it's going to start off as the number 0. So this is the instance variable that's going to change over time. Every time a user presses that blue button on the bottom right-hand side, we're going to attempt to increment the value of this counter variable by 1. And every time a user presses the button, we're also going to try to reflect the new counter value on the screen of our device. All right, so that's step number 4. And finally, on to step number 5. So step number 5 right here is going to kind of have 2 steps associated with it on its own. So the first thing we need to do is make sure that we are changing that widget state's data. So that would be the instance variable that we just created. So let's take care of that first. Let's think about where we need to increment that counter variable. Well, we want to make sure anytime someone presses the floating action button right here, we increment the counter variable. If you recall, when we created the floating action button, we created this onPressed property and assigned a function to it. We then saw that anytime user pressed this button, this function would be invoked. And so it seems to me like this would be the perfect place to take that counter variable and increment it by 1. So inside of the onPressed function, I'll add on counter plus equals 1, like so. So now every time we press the button, boom, counter incremented. So we now have some data that is changing over the life cycle of our application. Now on to step number 2 of this step number 5, I guess, part 2 of step number 5. So now we've changed our class data. We now need to call the setState method. So the setState method is provided to our appState class when we extend the state base class. So there is a method inside of the state thing right here called setState. And you and I are required to call it anytime our data changes and we want to get this component to update on the screen of our device. So right underneath the counter increment, I'm going to call setState, like so. Now you'll notice that I get the red squiggly right here. When we call setState, we are actually required to pass in a function. That's what this means right here. So we have to pass a function into setState. And inside of that function is where you and I are supposed to do our data modification. So right now, we just put down some code to increment counter outside of setState. This is not 100% correct. We're supposed to modify our instance variable inside of the function that we pass to setState. So let's do that refactor right now. I'm going to add in a function right here. Come on, there we go. Oh, no, one more, there we go. And I'm going to make sure that I mutate or change my instance variable inside of setState, like so. Okay, so that's it. That is the entire refactor. We now have a stateful widget called app that depends upon the widget state of appState. Anytime a user presses on our floating action button right here, we're going to increment the value of the counter variable. Now that's it for the refactor in terms of turning a stateless widget into a stateful widget. But to actually get our application working the way we expect, there's one last little thing we have to do. We have to make sure that the counter actually gets displayed somewhere within our widget. So right now we're incrementing the value of counter, but we never actually show it on the screen of our device. So to get it to show up on the screen, we're going to add one additional property to our scaffold widget right here. And we're going to make sure that that additional property gets our counter to show up on the device. Let's take a quick glance at the scaffold documentation, just so you get a good idea of where this is going to come from. So back at my widget documentation, let me get this up here. I'm going to do a search on the top right-hand side for scaffold again. And then down for the constructor of scaffold, you'll notice that there's the body property right here. So if we pass a widget to the body property of scaffold, the scaffold will show that on the body of the screen. So basically that counter variable will show up right here, which is exactly what we want. So back over inside of my scaffold widget, I'll add on the body property, and I'll have this be some text that's going to interpolate the counter variable in, like so. The text widget right here always expects to be called with a string, so that's why we are taking the counter variable and shoving it into the string. Counter itself is an integer, and the text widget does not want to see an integer. It wants to see a string. So we're just doing a quick kind of conversion right here of that integer into a string. So I'll now save this. We'll flip back over to our terminal. I'll do a full reload with Shift-R, and then we'll test this out on our device. All right, so it's going to take, I don't know, it always takes me like, there we go, 10 seconds. That's pretty quick. All right, so it's really, really small, but you might be able to see there is, in fact, a 0 right there. So now I'm going to press my button, and when I do so, you'll notice that that counter is incrementing successfully. So it's going up to 10, 11, 12, 13, 14, 15. You get the idea. Okay, so it looks like we definitely have the ability to create some data that's going to change over time inside of our application. But it absolutely involved a lot of very strange code. So let's take a quick pause right here. We're going to come back to the next section, and we're going to talk about one little bit of weird syntax, specifically this state less than greater than app thing right here. And then we'll do a quick overview on why we had to write all this complicated code to make a stateful widget. So quick break, and I'll see you in just a minute. In the last section, we started splitting our app into two separate classes in order to refactor it to be a stateful widget. I know this stuff is a little bit crazy right now, but just bear with me for a little bit longer. After we cover just a little bit more content, I'll give you a really good overview on all this stateful stuff, and I'll show you the exact steps you can use to create stateful widgets on your own projects. For now, I want to cover one last little confusing thing, specifically the syntax that we used right here. So we wrote out this little bit of code at the very end of the section. We wrote state, the less than sign, greater than sign, and then we put our app class in between. So we're going to flip on over to Dartpad very quickly, and we're going to write out a little bit of code to give you a better idea of what's going on with the syntax. All right, so back inside my browser, I've got Dartpad open right here. So we're going to write out some code to simulate a very classic game. A game of putting a square peg into a round hole. Now, as you might guess, we cannot put a square peg into a round hole. It just does not fit. I want to try to create three classes. I want to make one class to represent the slot right here. I want to create another class to represent this square peg, and I want to make a third class to represent a circular peg as well. All right, so let's write these out in Dartpad. And I know this might seem confusing right now, but don't worry, you'll see where I'm going with this in just a moment. So back over here, I'll put my main function. Underneath that, I'll do a class of circle. I'll do a class of square, and then I'll do a class of slot. Now the slot class might have a method tied to it called something like insert. Whenever we create an instance of slot, we would probably need to somehow say whether this is a slot meant for a circle or for a square. Because when it comes time to call insert right here, we definitely would want to annotate the argument type that comes into this method. So I would really want to be able to write out something like circle, my circle, or like, circle, peg, or something like that. So when I create my slot class instance, I really need to know if this is a slot made for a circle or if it's a slot made for a square. Now you might be thinking, well, Stephen, let's make like, a square slot and a circle slot. But you know what? Everything about this slot class between these two shapes would be probably completely identical, except for the circle or the shape that it accepts. So in order to solve this problem, Dart includes the idea of something called generics. A generic allows us to write much more, suffice it, lack of a better term, a much more generic code that's reusable between different types that we might create inside of our application. So in order to solve this issue of insert needing to accept either a circle or a square, I'm going to turn this slot class into a generic class. To do so, I'm going to put that less than sign, greater than sign, like so. I'm going to put a capital T inside there. And then down here inside of insert, I'm going to put a T. shape, and I'll just leave it like that. Okay, so let's now go up to our main function up here, and you'll see where this less than greater sign comes into play. So I'm going to first create a slot, so an instance of slot right here that is meant to accept only circles. So to do so, I might write out circle slot is new slot, and then here's where it gets interesting. I'm going to put my less than greater than sign, and I'm going to say that I am making a slot class instance that expects to receive the circle type, like so. So you can almost think of this as being like a type or a function invocation for types. That's almost what it is. This is saying create a new instance of slot, and anywhere that the class definition down here has a t, substitute the circle type for t. So now we can imagine that our insert method down here is expecting to receive a shape of type circle, specifically because we created our slot instance with the circle type right here. So now I can call circle slot dot insert, and I can try to put a circle in there, and there's going to be no issue with that whatsoever. But if I instead try to put a square in there, well, now all of a sudden everything's going to be complaining. It says the argument type square, because that's what I'm trying to pass in there, cannot be assigned to parameter type circle. So when you see these less than greater than signs with a type in between, that's our ability to write a generic class. And a generic class is all about writing some logic that we want to be reusable between different types. But for all the methods inside of our given class, we want them all to respect that one type. So that's what's going on over here. We're saying that we want to create an app state class. It's going to borrow a ton of functionality from the base class of state. Inside of that base class, there's a bunch of methods that are only supposed to work with one specific type. And so by putting inside of here, the app class that we just put together, we're saying we want to create a copy of that state class that is customized to work specifically with the app type. Okay, so that's what's going on. Now, we're not going to talk too much about like what the state class is actually doing internally. Everything we just spoke about kind of like accepting these different types, that's really all we need to know right now about the fact that we're using a generic right here. So all I wanted to do was kind of expound on the syntax. I don't really want to talk anything just yet about what the state class is really doing for us. All right, so now that we've got a better idea of what's going on right here, we're going to continue in the next section. And we're going to add in a little bit of state to our project, and we're going to get that number to increment every time we press that button. And then right after that, we'll do a big review on the stateful widget stuff, and I'll give you a very clear series of steps that you can go through to create stateful widgets on your own project. So quick break, and I'll see you in just a minute. In the last section, we spoke about some of the weird syntax right here. We're going to now have a very quick discussion and talk about why we had such a painful refactor to take our app over to a stateful widget. In other words, why did we have to create two separate classes right here? And why did our app widget have to have a createState method tied to it? Well, let's take a look at a diagram that's going to help us understand what's going on. Okay, so this is a flow diagram of what would happen if we did not have a stateful widget. That's the key, okay? So this is how life would be if we did not have stateful widgets. So let's walk through the flow here. At the very start, Flutter would decide to look at our app and render our widget on the screen of our device. Now we'll assume that our stateless widget of app right here, again this is considering the case we did not have a stateful widget, would create a new instance of our app widget. That app widget might have a counter variable assigned to it of 0. And so that new app widget would display the number 0 on the screen. So then maybe at some point in time, a user presses that button, and that increments the value of counter to 1. Now here's the key part. If Flutter then decided to re-render our application, it would create a new instance of our app widget. So we would now have two instances of the app class in play. We have the old copy that now has a counter value of 1 assigned to it, but Flutter, when it re-rendered our application, created a second instance of app. And that second instance has the initial value of counter assigned to it of 0. Flutter throws away the old copy of app, and it decides to now use the new one to represent our app widget on the screen of the device. And so when Flutter re-renders our application with this new copy of app, we still have the 0 value of counter. And so we still see 0 on the screen. Now the real key here, the key thing to understand, is why Flutter decides to create a new instance of our app widget. And the best way I can show you that is by pointing out the build method right here. So whenever Flutter tries to re-render our application, it's going to call the build method on every widget that we have inside of our application. When you look at this build method, you'll notice that every single widget that we create inside of here is created from scratch. So material app right here is a new instance of the material app class. This is a new instance of scaffold, a new instance of text, a new instance of floating action button. So every time that Flutter decides to re-render our application, it is creating a new instance of these widgets. So all the old instances get thrown away, and we create these new ones. And when we get this new instance of this widget, it comes with a completely reinitialized set of instance variables. So if we did not have stateful widgets, we would never see any changes appear on the screen of our device. Okay, so let's now talk about what's happening thanks to the fact that we do have stateful widgets. You know, what's happening now that we have these two separate classes? All right, so slightly different flow diagram here. So this is with stateful widgets. So we start off again with Flutter deciding to render our app on the screen of the device. It creates a new instance of the app widget. So here's the app widget right here. Like that's the top class, this one right here. When that widget is created, when the app widget is created, Flutter is then going to automatically call the createState method on that widget. So the createState method that you and I defined. So that's createState right here. Inside of createState, we create a new instance of appState and return it from that method. Flutter is going to take that appState object that we just created and it caches it. So it holds onto it and it does not throw it away. Then whenever a user presses that button, the counter will increment by 1. And because you and I called setState inside of our appState widget, Flutter decides to re-render our application. So at that point, a new instance of the app widget is created, just as it did before over on this diagram. But the old copy of appState is kept around. So we are not creating a new copy of appState, because that appState object gets cached and it sits around no matter how many times Flutter decides to re-render our application. Because appState does not get re-rendered, or excuse me, because appState does not get recreated, its instance variables do not get reset, or they don't get initialized back to their starting values. So we then re-render our app widget, but it uses this original copy of appState where the counter value is still set to 1. I think another diagram that might be helpful to take a quick glance at is this one right here. So here's our widget tree again. At the very top, we've got that app widget. So that's the original one right here, the first class we put together. And anytime the app is first created, we produce a new instance of appState through the createState method. So this widget right here, that first class that we put together, this thing is going to be thrown away, recreated many times in the lifecycle of our application. But the appState object over here only created one time. And then we hold on to it for as long as our app is running or until we decide that we don't want to render this widget on the screen anymore. Okay, so hopefully that gives you a better idea of why we have to create two classes right here. It's all because whenever Flutter decides to re-render our application, it's going to throw away this widget and it's going to try to recreate it. If we recreated it, then we would lose all the data that we had tied to that widget previously. So by making sure that we have this createState method right here, along with a separate appState class, we're going to hold on to our instance of the appState that is created no matter how many times our application is re-rendered. All right, so I think we got a better idea of what's going on here. So let's take a quick pause and we'll continue in the next section.